Hi and welcome to our next video from the numerical methods section from the year 2 part of the A-level maths course, and in this one we're looking at iteration again. We went through the basic ideas of the technique last time. This time we're looking at some of the issues surrounding it. I've got the title as choosing the appropriate formula, because what we're going to see is that sometimes we're going to get an iteration formula that doesn't work or doesn't actually find the route that you're looking for. And the other thing we're going to look at is partly the links to the reason why it doesn't work, are these things that are on that bottom bullet point there, which are staircase and cobweb diagrams. So off we go. Here's a cubic. So we've got the graph there, and it says using that information find all the roots of x cubed minus 4x plus 2 equals 0. So off we go. So what I've done first of all is come up with an iteration formula. So I've rearranged it, and essentially what I've done is taken that term in x, then made that the subject. So you hopefully can see where that 4xn minus 2 is coming from. Now if you want to do that one, I'm just going to pause the video, because in a second I'm just going to pop the answer on the screen. I'm not going to actually demonstrate the technique again. I think we've probably done plenty of that in the previous video. So what we should get first of all from that one is x equals 1.675, and the other one that we find is x equals minus 2.24. Now what those roots you found depend on where you started off. If you start off with a starting value maybe of 2, you'd have got to this value here. If you just start off with a starting value maybe at 0 or minus 1 or minus 2, you'd have ended up at this one down here. What you need to try and do now though is we've found these two. It may be that you've not been able to find this one in here. So if you haven't found that one yet, then have a go at that. We can see it's between 0 and 1. It's kind of in the middle, so maybe you want to try a starting value of 0.5 and see what happens. And again, if you want to do that and have a little play around, then pause the video. But if not, what we find is that we're just using this formula, we're just not able to find that particular root there at all. It just won't work. It might be you started off with a starting value of 0.05, and I think that would have taken you to this root down here. If you start off with 0.6, you'd have got to this one up here. It's just not physically possible to find that root, so that seems a little bit weird. However, if we go back to our original formula and come up with a different iteration formula, this one here I got from making this particular x term the subject. Let's now make this term the subject. So what we get is that. I'll just move the 4x over. Now do the divide by 4. There we go. There's another arrangement of it, say x equals. Let's turn that into an iteration formula, and now if you use that iteration formula you should hopefully be able to find that missing root, and if you've done that you'll find you've got a value of x equals 0.539 as being the missing one. Now the next thing to look at is to see, well, let's see, will this formula work for the other roots? So maybe if you try a starting value of 2 into this formula and see what happens. Or if you try maybe starting with minus 2 to find this root and put it into this formula, see if that works. But what you'll find is it just doesn't work. So what I'm going to do now is just kind of jump into Excel and have a little look at what's going on. So here's my graph from my previous screen. What I've done is set up Excel just to essentially do the iteration. So what we've got here, I'm going to go this blue table, calculate values using this formula here. So if we start off with a starting value of 0, for example, if I put that in, you'll notice straight away it goes through the iterations, and we've ended up at this minus 2.214 root. So what I want to do is, like, let's say I'm going to try and find this 0.539. So let's try a different value. Let's try a bit closer. Let's go 0.5. See what happens. That's still no use. It's still, even at starting at 0.5, it's still jumping down to this one. Let's go a bit further and go 0.539, and this one is slightly mind-blowing. Here we go. Look at that. Even though we've done this to 3 decimal places, it's still gone from here, and our iteration formula has taken us down to this one. Okay, so 0.539 isn't working. Let's go just a little bit above the root. So let's go 0.54. See what happens there, and you can probably guess what's going to happen. Look at that, lo and behold, it's completely ignored this root again, and it's jumped now to our 1.675 value. So whatever values we use, and we could play around this with all day, this formula here, no matter how close we get to our actual root, it's not going to find it. However, if we go for this one, pick a value of 0, There you go. That's absolutely fine. What I'm going to do, just for sports, this is what we've got, 0.5391889. Let's put that in. So we've got 0.539. Oh, I think I've typed that wrong. Let's try again. 0.5391889. Where's it going to go to? Look at that. It's actually gone and found this route again. That's just bizarre. And the same thing will happen if we go for this table here. So let's pick a starting value. We've seen if we start at 0, it's going to go straight to this route here. Let's try and make it, let's say, find this bottom route. So let's go for minus 2.214 and see what happens. Look at that. It's gone straight to the middle route again. Let's go a little bit lower than that. So let's go minus 2.215 and see what happens. Okay, well, that's all bizarre. Now, what we've got going on here, by the time you get to this value here, that e plus 09, that's Excel's way of doing standard form, so that's minus 4.37 times 10 to the power 9. By the time we get down to here, we're at minus 2.8 times 10 to the power 252, so that's kind of 252 zeros, and at that point Excel just gives up. So what's happening is, using this formula, it's just disappearing off the bottom, and it's going on and on and on off to infinity, and it's not finding that route at all. Let's have a look at this route up here. So if I use a starting value, you choose a starting value of, let's go 1.6. There you go, it's gone straight back to our route there. And if I pick a value, let's go 1.68, you can probably guess by now what's going to happen. There you go, it's disappeared off to infinity again. Let's say it's given up by the time you get to 1.88 times 10 to the 156. So long story short is that certain formulae won't find routes, which is a little bit bizarre, but what we'll do is have a look at why that's happening. So there's our 3 routes, and in order to understand what's going on, we just need to look at, in a little bit more detail, at the actual graphs of the iteration formulas. So let's start with that one. What I've done is taken my iteration formula, and the blue line is just the curve y equals the cube root of 4x minus 2. Now that's essentially what we've got is, or essentially this thing here is essentially that formula there. I've taken out the kind of the iterative part of it, and this thing here is something that provides us with the solutions to the simultaneous equations y equals x and y equals cube root of 4x minus 2. And straight away from that we can see we've got 3 solutions. 1, 2, 3, and hopefully you can see this one here is just below minus 2, so that's the minus 2.214 I think it was. There's our middle route, the 0.539, and there's our upper route, the 1.645 that we saw previously. So there's our 3 routes, and let's just have a look at how the formula functions. Let's do a bit of zooming in just at the top one. So what we've got here is a zoomed in version. You can see I've got the 2 routes here. What I'm going to do is explore what happens. So let's start off with our first starting formula, x equals 1. So what I'm going to do is put x equals 1, what I do with iteration, put it in, and what it does is gives me effectively the y value from y equals cube root of 4x minus 2. So I'm basically going up and I'm hitting the curve here and getting my y value. And then what I'm doing then is saying, well, I need to transfer that to be the next x value. So what I do is go across and swap the x and the y values around, and that gives me x2. Because I put x2 into here and put it into this thing, and that gives me my next y value. And then again switch it over, so we've got our next one, putting it in the next. So I'm using our result from x2 to become x3, put that in, and you can see what's happening is we get closer and closer until we get to our route, and this thing is called, for obvious reasons, a staircase diagram. Now, that's an example where the route was found. Let's have a look at when it won't find the route. And so let's have a look and see, there's our curve. Let's see if we can find that middle route. The one we know we're going to be unsuccessful with this, but let's just have a look at what happens. So if we start just above the route, that's basically what we had before from the previous slide. Our staircase takes us away from the direction we wanted to go. We wanted to find this route here, but our staircase has moved us up to this one. If we start just below the route, so I'm starting off with the new x1, you can see it's giving me this value here, and let's just now look what happens. Well, the staircase again is taking us away. And so what it's going to find is that route there. So no matter what we do, both staircases in that example takes us away from the route that we're actually looking for. The reason that's happening is because close to the route, what we've got is a very, very steep gradient. Technically speaking, if you end up with a gradient of greater than 1, or for curves going the other way, less than -1, you're not going to be able to find the route. But you'll notice what we are finding up here, we've got a much shallower gradient around this route, and we've got a shallow gradient around this route as well. So that's why this is working. This fact here is why it's happening. That doesn't really get investigated in a major way on the A-level spec. You just need to be able to essentially reproduce the staircase diagram. Right. Let's have a look at what happens with the other rearrangement. So this one is y equals x cubed plus 2 all over 4. So this was the one that will find our middle root. So what I'm doing is I'm starting off with the value of x1 that's down near -2, and we know this is not going to find the root there. It's actually going to find our root here. Let's see what's going on with this one. So there we go, and you can see straight away there's our staircase functioning in the same way, and it's taking us to that middle root. And finally, the other thing to note is, when we saw it on the Excel sheet, if I take a starting value that's just to the other side of this root here, what will happen? It will diverge, and it'll just disappear off to infinity, and it won't find any root at all. Okay, so that's our staircase diagrams. You can get another type of diagram, which is called a cobweb diagram. And what happens here is you get successive iterations alternate above and below the root. And this one happens if we've got a curve with a negative gradient. So let's just have a quick look. So there's my starting value. And you can see I've got a root going on here. So let's just have a look at what's going to happen. So I put in x1. It spits out the y value, which is somewhere around about -1. So then I'm going to transfer that to be my next value that I'm going to put into the formula. And so put that one in, and then transfer it across. So this one was above the root, so x3 is my next value. So when I put that in, there it goes. I get another value this time, so this one is below, and then so on and so forth. And you can see you get this spiraling. I'll trace it because what's going is going here, round there, and you can see this kind of spiraling that is happening around it, and it will keep spiraling around until we get to the root in the middle. So that one is referred to as a cobweb diagram. So you might get a question that says, let's say if you see successive iterations that are alternating above and below the root, then you know that's going to translate to a cobweb diagram. Okay, and there you go. And so there's all the bits and pieces surrounding iteration.